Welcome to episode 3 of BAMTV. My name's Phil Zito. I'm the owner of Building Automation Monthly, and I'm going to be talking to you today about optimization in this BAMTV episode. Optimization is a topic that a lot of folks like to think they understand, but when you ask them to start explaining it to you, you start to get all sorts of different answers. You get everything from optimization is really retro commissioning, optimization is just adjusting set points, optimization is energy efficiency. It's all over the map. So really, what is optimization? What is it? Well, optimization is taking something, usually a sequence of operations, and going and enhancing it so that it meets an outcome without changing the original purpose of that sequence. So, for example, we have an air handler. That air handler exists to provide 55-degree discharge air to a space or to a series of VAV boxes. Well, in an optimization strategy, we may go and optimize a part of that air handler or the entire air handler itself. So we may go and optimize the economizer. We may go and take the economizer section of the air handler and take it from a simple open-close economizer and optimize it to control off of mixed air temperature or to control off of return air CO2. However, the purpose of that air handler remains the same, to provide 55-degree discharge air. Where optimization starts to go wrong, and something we're going to dive into a lot in this episode, is when folks don't think through the upstream and downstream effects of optimization. So for example, let's say we have a building here. Okay, we have a building, and one of the latest things in buildings, and I totally get this, working in a filming studio that has one window, I understand how refreshing natural light is. So one of the things that a lot of folks like to do is inside a building, you've got your worker right here, and this worker, they want to expose as much of the space to natural lighting to really empower that worker. There's multiple studies about the effect of natural lighting on folks within a office space. However, if you just simply go and you implement a daylighting strategy without thinking of the upstream effects of that daylighting strategy, now you've introduced thermal loads, especially if it's a southern facing window. So a thermal load would be the sun coming and all of the BTUs coming through here and hitting surfaces. Maybe he's at a desk, hitting that surface and heating it up. And now that desk is holding heat in that space. And that is more thermal load that your building automation system, through utilizing and controlling the HVAC systems, has to remove from the space. I remember this like it was the other day. My team and I were working on a police station in Dallas, Texas. And this police station had floor-to-ceiling windows, much like this. And the room was southern-facing, and the room was always hot. And so what had to be done is the room was designed much like the northern-facing rooms and the eastern-facing rooms and the western-facing rooms. But two critical things were not taken into account. It was designed like an exterior room, but one, the fact that it was floor-to-ceiling windows with no glazing wasn't addressed, glazing being the kind of shading and different materials you could put on windows to help block solar gain, things like that. Second thing that was not factored in to this right here was that this designer did not factor in the fact that more heat had to be removed, thus the flow in and out of the space had to be higher. So because of those two things, the upstream effect was a greater thermal load on the system. Now, Another thing you see quite often is where folks will go and they'll say, hey, I want to stage up my equipment, but I want to stage it piece by piece because I want to avoid demand peaks. Basically, you pay for electricity in two ways. You pay demand and you pay consumption. Consumption is your kilowatt hours, demand is your kilowatt, at least when we're dealing with electricity. Now, you have what in most cases, not all, are called ratchets, meaning that you can go up to a certain amount of demand because demand is what the utility has to provide you versus consumption is just what you're consuming. So you can go up to a certain point of kilowatts. However, after you exceed that, you're locked in for a year to this new rate structure. So what a lot of folks will do is they will try to avoid hitting that peak demand, especially since when you turn on equipment, that's when the largest demand draw tends to happen versus when the equipment is operating. That's why things like VFDs are so attractive, not only because they allow you to use equipment efficiently, they also allow you to use equipment with soft start. So you're not just slamming your kilowatt, not slamming your demand. Well, the problem is with optimizing equipment to stage on gradually, if you're in design day conditions, either cooling or heating, you can actually go and cause your building to get locked in this kind of situation where there's so much heat buildup or so much heat drain that your building can't catch up during a normal 10 to 12 hour cycle. So that has a downstream effect. So while as the daylighting that I just described had an upstream effect, the optimizing of equipment to stage can have a downstream effect on comfort. So you can see how optimization, while well-meaning, if not properly done, can cause some major upstream and downstream issues. Now, one thing that I really want to focus in on, it's something that is rampant in the industry, something that I've heard from my students that they are challenged by, and something that a lot of owners are challenged by. And that is the difference of optimization and retro commissioning. The two are not the same. Optimization seeks to take a sequence and modify it to perform the same outcome more efficiently. Hence our economizer example earlier. Whereas retro commissioning seeks to validate that the existing sequence is performing as designed. Because as we all know, or maybe you don't know, but if you've been in the field for any amount of time, you probably do. The 6 months to 12 months after a building has been built and occupied are usually the most damaging to its performance. Poorly trained operators, trained by contractors who are rushed and are trying to get to the next job so they don't properly train them and onboard them to the system. These operators revert back to what they know, which is usually running stuff in hand and override. That, coupled with poor alarm strategies, tends to result in buildings that just get out of whack and perform poorly. So what do you do? Well, what folks are doing lately is retro commissioning. They are hiring a retro commissioning agent to come on board and to essentially recommission these buildings, make sure they operate as designed. Here's the problem with this. There's kind of three things that are happening. One, folks are just being cheap. You get what you pay for. If you pay for quality, you get quality. You pay for cheap, you get cheap. That's why I'm not a fan of going and value engineering things. I've seen it just do so much harm and ultimately cost the owner more. However, that's not what we're talking about here. So what I mean by folks not wanting to spend the money is they retro commission the central plant, or they retro commission a couple air handlers. But we know this, and you know this if you've been following Building Automation Monthly's teachings for any amount of time. You know that we subscribe to a systems thinking methodology. We subscribe to the belief that technicians, salespeople, and engineers need to think from a systems mindset. They need to think, how will this change in this affect everything downstream and upstream? When you only retro commission one part of the system, you're not embracing a systems thinking mindset rather. You're embracing a individual equipment mindset. And all of the downstream and upstream effects can actually be made worse by properly performing equipment. I know I actually chuckled there a little bit, but I've seen it time and time again where properly commissioned equipment controlling systems that are then feeding or are being fed by systems that are not controlling properly can actually cause more problems. This is where you go retrofit a central plant, but you still have actuators from the 1970s that aren't controlling. And now all of a sudden you're realizing, oh man, I've got better visibility of this plant. Where are all my BTUs going? Well, they're going into these coils that are wide open because none of the actuators work. So that is one, right? The second thing is retro commissioning, but thinking you're optimizing. Going and instead of retro commissioning, you're actually just changing a sequence that didn't work in the first place. So that is really ugly in itself as well. Now, the third is when you kind of retro commission and you kind of optimize at the same time, and you end up with this Frankenstein monster that doesn't quite really work. Things are conflicting. The systems are challenging one another. This is kind of the worst scenario. So, what does optimization assume? Optimization assumes, and if you get one thing out of this video, it's this right here. Optimization assumes that the system is operating properly and has been commissioned. If the system is not being commissioned, do not do optimization. Spend your money on commissioning. If someone is coming to you and they're selling you optimization on a system that is 10, 20 years old, or if you are someone who is trying to sell optimization on a system that is 10, 20 years old, heck, maybe even 5 years old, you are not doing your customer any favors, and customers, owners, you're not making a good investment of your dollars if you do not verify that everything works prior to optimizing. Because all you're doing is you're taking a Yugo and you're finding a body frame for a Ferrari, and you're putting that body frame for a Ferrari on that Yugo, but it's still a Yugo. It's going to perform like a Yugo. And that will be a major problem for you as you go about optimizing your building automation system. Okay, so with all that fundamental knowledge in place, we now are going to move through my 5-step optimization process. I've used this time and time again on many projects, and I've seen great results from this. So the first thing you want to do, the first step, is to go and identify the goal and the outcome. So step 1, we're going to identify our goals and outcomes. Okay? So what I want you to realize is that goals and outcomes are not the same thing, okay? Outcomes are maybe you want to run a piece of equipment more efficiently. Goals are how are you going to measure that efficiency. So it's important to have both and to be very clear on both, because what you can do is you can say, we're going to do a project and we want to have better control of the temperature within the spaces that our tenants are working, okay? We want to have better temperature control. Now, a goal is how you're going to measure that you have better temperature control. Are you going to measure it by decreased complaints? Are you going to measure it by adherence to set point? Are you going to measure it by a comfort survey? That goal will then define how you're going to measure it. And that's very important, because knowing your goal is going to determine what you are going to be doing as part of your optimization strategy. For example, if our goal is to improve, or our outcome is to improve tenant comfort, and we know that our goal is to measure temperature, that is different than if tenant comfort is defined by better chairs or by better lighting. Those may be how we achieve tenant comfort. However, if we know that our goal is increased temperature accuracy, then we know we need to validate that our temperature sensors are accurate, that our set points are accurate, that our flows for the spaces are properly designed for the loads. These are all things we take into account, versus if it's really just tenants don't like the lighting that's in the space, then we change out the lighting. That's completely different. All right, number 2, identify the ways to achieve the goal. So this is how to achieve the goal. Okay? So how do we go about achieving this goal? This is where you're going to sit down by yourself. I'm not a big fan, and there's been multiple studies shown that brainstorming is actually a poor way to come up with ideas. One, you're often paired up with folks who don't understand what you do or the impacts of the suggestions they're making. 2, it actually stifles your creative process, because whether you know it or not, you will hold back from certain things because you don't want to damage your social approval within the group you're in. So I recommend you do this on your own. You identify the ways to achieve the goal. So how are you going to achieve the goal? So if it is indeed the temperature of the space, well, we could go and, verify sensors. We could check CFMs. We could calibrate loops. Spell calibrate right. There's a variety of ways we could do this, okay? You need to list those out. Number 3, you want to weigh the pros and cons of each way that you're going to achieve the goal, and determine the cost of doing that and servicing that. So verifying and actually you may do all of these. You may do none of these, but you want to go and weigh the pros and cons. So you make a pros and cons list. So we're going to put here pros and cons of actions. Okay? That's number 3. Once you've done that, then you narrow it down, you start ranking the list. You look at the pros, you look at the cons, you look at the installed cost, yes, for those of you who are first cost thinkers, but you also look at the life cycle cost. This is something a lot of folks miss in capital events. They don't realize who's going to operate this. If we don't properly train and fund the operation of some of these changes, we'll just be back in the exact same spot a year from now, because we've gone and not really dealt with the reason we're in this spot to begin with. Maybe it's a poorly trained operator. Maybe it's not having proper maintenance done because we're not properly funding our maintenance group. There's a variety of things we need to make sure we address, and that is how we are going to go and rank the items. And finally, number 5, everyone's favorite thing that we like to just skip to, and that is implement. So everyone, I don't want to say everyone, I try to keep myself from saying everyone, and that's something I challenge all of you to do as well, because we have a tendency to make statements in positions of authority. So I'm a thought leader in the building automation space. And you may be a thought leader in your business or in your space, or a thought leader to your customers as a service technician or a service manager. And I challenge you to not make absolutist statements. That's something I myself personally are working on, because You do not want to make statements of fact without being 100% clear on what you're making a statement about, because that's how you end up in these situations. I know for a fact that it's the sensors that are bad. So if we just go fix the sensors, you'll have temperature control. You go fix the sensors, no one checked the CFM, no one checked the dampers, no one checked the air handlers, and you still got problems. This is why you need to avoid the tendency to listen to the loudest voice in the room. You need to go, and I know this sounds like I'm contradicting when I'm saying go and do step 2, which is identify how you're going to achieve the goal. You should still, before you implement, go and get feedback on the ideas you've come up with. Validate that they indeed address the problem. And then, and only then, do you go and implement. So many folks will hear, and salespeople and technicians and managers, we know all of us have been guilty of doing this before, where we hear the customer say a problem, we immediately think in our head, we know what the problem is, and we immediately move to implement. And we want to avoid doing that. That causes significant problems. That is why you need to have a plan. And what I recommend, based on my experience, having led large teams, both on the operations side, the integration side, and the analytics side of the building automation business, and having taught over 2,400 students here at Building Automation Monthly, I highly recommend you get into a process mindset, you follow a process, and you implement the process, and you will see greater results in your business. Thank you so much for watching this episode. If you've got any questions, go below the episode in the comment section and leave them. If you'd like to see me cover anything in a future BAMTV episode, let me know. And if you would like to grow your own building automation knowledge without ever leaving your house, get the same level of insight and growth that I've brought to you in this free video, then I encourage you to check out our building automation training courses at buildingautomationmonthly.com/store. All courses are fully online. They come with lifetime access to the course. And that means that you don't have to travel. And if you ever forget anything, you can go and watch the videos again. Thank you so much for watching this episode of BAMTV. And I look forward to talking to you again next week. Take care.